Hello everyone, I am Nandakumar, studying Electronics and Communication Engineering at NPR College of Engineering and Technology. I thank Emertxe for this wonderful opportunity to enrich my skills and develop my knowledge in embedded systems. I learned many things throughout the internship. Once again, I thanks Emertxe for this wonderful opportunity. I am here to present you that car black box. How that car black box work? We can see that the flights have black box. Now we going to implement that how the car black box works. Let's move on to the video. The presentation has two slides. First slide is about what I learned throughout the internship. Second slide is about the demo. How I implement the car black box in a PICSIM laboratory. Yeah, we can first move on to the slide one. The slide one contains the what I learned through the internship about the C language, about how switches and other works. Yeah, let's go to the first slide. The contents of the internship: C programming and embedded C, microcontroller and microprocessor, embedded system, project description. C programming. C program is a general purpose procedural imperative computer programming language. C program is used in system software development, embedded software development, OS kernel development, firmware, middleware, driver development, file system development, as many more. C used effectively in various specific domains. It is a free format language and not strongly typed language. Efficiency and portability are important considerations. Library facilities play an important role in C. Let's move on to the embedded C features. Number systems. There are number system are decimal, octal, hexadecimal, binary. Data representation, bit, byte, word, integrated number, positive, negative. Data types, integral. Integral contains character and a integer, floating point, float and double. These are the data types present in C. The data type modifiers are the size modifier short, long, long, sign as the positive and negative determines, signed, unsigned. Data type qualifier constant and volatile. Constant we cannot change that afterwards. The conditional constructs. The conditional is single iteration if else, if and switch case, multiple iteration while, do while and for loop, unconditional, continue and break. The operators, which is operates on its operands, returns a value. Operators may be arithmetic, logical, relational, assignment and bitwise operators. Overflow, underflow. The overflow and underflow plays an important role in C language. Array is a collection of data of similar data type. Addresses are sequential, first element with the lowest address and last element with the highest address. Pointers embedded in data structures such as arrays, structures and unions. Parameter passing mechanism in function by passing the reference. The pointer is assigned null is called null pointer, which is pointing to nothing. Functions performing a specific service. Parameter passing type, pass by value, pass by reference. Functions, passing array, returning array and recursive. Strings, contiguous sequence of character, easily stores ASCII and its extensions. Storage class, auto, register, static local, static global and extern. Preprocessor is header files and source files. We are going to move to microcontroller. An integrated circuit which is capable of being programmed to perform a specific task. Embedded inside device used to control the action and features of a product. All components in a single chip, less flexible, less design complexity. Things to be noted when choosing microcontroller. They are applications, performance and price, availability of tools, special capabilities. These are the things we need to note down when choosing a microcontroller. Analog to digital converter, microprocessor and a RAM, and programmable memory. These are the things placed inside the microcontroller. Microprocessor is a computer process where there is a data processing and control is included on a single integrated circuit or a small number of integrated circuits, all separate components, more flexible and more design complexity. The microprocessor contain ALU, control unit, register array, and input device and output device, and it has a separate memory unit. These are the things present in the microprocessor. Let's move on to embedded system. Any combination of hardware and software which is intended to a specific task can be called as an embedded system. A general purpose system is used to perform a large number of tasks, whereas embedded system is used to particular perform a specific task. The challenges in an embedded system are efficient input and output, embedding an OS, code optimization, testing and debugging. These are the challenges in embedded system. The categories of embedded system are standalone system. In standalone system there are two types of system: slave system. These systems are not intelligent even though these are embedded system. This system cannot take action by their own. Semi-automatic washing machine. Independent system. This system can take action by their own. Example car, driverless car. Real-time system. These systems are time-bound system which will take action on a specific time. Failure in the system are not acceptable. Example airbag system. The other one type is network system. This system which are connected to the network. Example home security system. And the other option is a mobile system. We are controlling the mobile devices. The system which is movable are called mobile system. Example robots. The real-time aspects: hard real time and firm real time and soft real time. In hard real time should meet its deadline, life critical applications. The firm real time is similar to hard real time. Soft real time can have tolerance in meeting and its deadline. The components of the embedded system are CPU, digital to analog conversion, actuator, aux system and diagnostic port, and a electronic mechanical back. Next we move on to PIC 16F877A. It has 40 pins. It has 5 ports in total: port A, port B, port Z and port D and port E. It supports serial communication. For it has 2 pins, TX and RX. You can receive data from RX, you can transmit data from TX. We have to place crystal ranging from 4 MHz to 40 MHz. Moreover, we also need some programming or burner to upload hex file. This is the pin diagram of the PIC 16F87A. This is the block diagram. This is the block diagram of the microcontroller we used. This is PIC 16F877A. We have 3 timers. Let's move on to CLCD. CLCD is character liquid crystal display, and there are 2 types: 16x2 and 16x4. Used to display all ASCII characters and symbols. It has only 16 interface lines. The 16x2 is we used in this simulation. D0 to D7 are the data lines. It has built-in controller. It has own RAM and ROM. The controller can execute the instruction and data. RS line, register select line. RS value 1 data, RS value 0 is instruction. This is the model CLCD. We can see that it is a 16x2 CLCD. It has only 2 lines. It has 16 pins. We see the data processing in CLCD. Data processed by 2 method: delay method and a poll D7 method. In poll D7 method, we want to continuously monitor D7. In data lines, we are providing data. Write and write 1 equal to read, read and write 0 equal to write. In R and W pin is permanently grounded. That means only write and data. In CLCD, D0 to D7 are connected to port 7 and RS and enable pin are connected to port E. 8-bit means D0 to D7. 4-bit means D4 to D7. Enable pin acts as a integrator by appraising LCD about the inception of data transmission by the microcontroller. Tactile switch. Tactile switch is a switch whose operation is perceptible by touch. This switch is to select the mode of operation and to enter the temperature and to enter the time in our project. This switch will be produce a bouncing effect. Superior plus pulse detection while pressing and releasing the tactile switch is called bouncing effect when switch is pressed. There is a metal plate and a terminal. Triggering methods are edge triggering and level triggering. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in sync with the system clock or external clock. It has many applications such as measuring time and generating delays. Timer counter is a software design count the time interval between the events. PWM or pulse generator counter, PW or PP measurement. These are the three modes. Resolution is also called register with 18 or 60 bit. Here to toggle the LED, 8-bit resolution is used. Tick is referred as the change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be a pre-scaler or post-scaler. Next we want to interrupt. Interrupt is a communication process set up in microprocessor microcontroller in which an internal or external device requests the MPU or MCU to stop the processing. Then the MPU or MCU acknowledges the request and attend to the request. Goes back the processing where it is got interrupted. Polling. It is the process where the computer controlling device waits for an external device to check the relay or state, often with low level hardware. Disadvantage of polling. Loss of events may occur during polling. Poor response, less for management. Classification. Interrupt. Hardware interrupt, software interrupt. Hardware interrupt, maskable interrupt, non-maskable interrupt. These are the classification of the interrupts. ISR. ISR is interrupt service routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR attend to the request of an interrupting source by clearing the interrupt flag should save the register content that may be affected by the code in ISR. It must be terminated with the instruction retry. When an interrupt occurs, the MPU completes the instruction being executed, then it disables global interrupt enable. Thank you. This is the first slide. Then we move on to second slide. The second slide is a project description. In the project working, build a hex file in MPLAB XIDE and PIC board is PIC Genius board. Microcontroller is PIC 16F877A is the microcontroller we used in the project. Let's move on to the project simulation. This is the project. We have written the code. The code contains all ADC, car black box, CLCD, digital keypad, I2C and main and timers. These are the header files we used, and the main source files are adc.c, clcd.c, I2c.c and ISR we studied that is a interrupt we used there. These are the header files and source files. We will building the project is after the successfully building the project, we are going to take the hex file and simulate in PIC Genius. Simulate in PIC SimLab. PIC Genius is the board we are using. This is the PIC Genius. This is the PIC Genius board. We are using PIC SimLab, the simulator used to simulate the car black box. We need to load the hex file. We using the oscillation as 20 MHz. We can see the LCD, fan and the data memory, CPU and many other things. Load the hex file. We already built that. After successfully building, we need to load the hex file. After hex file, the PIC Genius board is turned on. The PIC SimLab started working. We can see that there is a time. E is the event that is currently on. We are going to, there is a memory data, there is a multiple pings to switch the LED to others. There are 3 switches, RB0, RB1. After kicking RB1, first C is the collision, is the first event. If we press the RB1, there is the event changed into car ground neutral, ground reverse and gear 1. and gear 2 after pressing RB1. Gear 3, if you press RB 1 by 1, it increase the gear. If you press the RB2, it reverse the gear from G4 to G3, now G2, and now currently G1. After each pressing, it comes backwards to the gear. We can see that display output in the LCD. It is switching across to LED display. The speed, SP is the speed. If we increase the potentiometer, we can see how the speed we can varies. There are three more switches. There are RB4, RB3 and RB5. The RB4 and RB5 is used to store as a password. We have a 4-pin password that is made up of RB4 and RB3. If there is a 4-pin password is a multiple. If we press the RB correct password, it goes. We can see that there is a view log, clear log. If we press RB4, it goes downwards. After pressing the RB4, we can see that clear log and change password. These are the things present in it. If we RB3, it goes up. We can see that view log. If we click RB5, in view log we can see that. If we click RB5, we can see the events which are that is working. If we press RB4, that it goes upwards and down. It goes top and down. This is the use of RB3 and RB4. Yes, now we are going to press. This is the first is the view log section. We are going to press RB5. If we press RB5, the first event record the event as G2 ground events, where the speed changes G2 35. After pressing down button, we can see the multiple of records. After the time there is each record for every time. We have to save 10 records. After the 10th record, it replaces the 0 record. It's a number 0 to 10 is 0 to 9. After the 10 records, it's replaces the 0 record and adds a new record. If you press that, we going to add enter password. Now we are going to clear the logs. If we press RB4, it go downward. Now we press the RB5. Now we want to press RB5 to clear the log. If we clear the log, we won't see that other logs present. The log cleared successfully. We can clear the logs. What are the events are recorded are now cleared. Now we go on to view logs. After clicking RB5, there is no logs. The display is output as no logs. Before that we create the logs, so it don't display the logs. Now we can see that there is no logs. This way we can change that logs. This way we can change the log, clear the logs. These are the use of the car black box. This is done by using the switch RB3, RB4. RB3 is going top, RB4 was going down. RB5 is used to click like a enter button. We going to switch on and we can going to reset the switch. Now we can see the timer is loading. Now we can see the watch enter the password. We enter a 4-pin password which is dependent by RB3 and RB4. We can see that view log, clear log. Now is the first log. We reset that, we switch on or switch off. Now we see that just see the first log only. There is no second log. After clicking that, now timer will be on RB4. After entering the correct password, we can see that view log, clear log. After pressing RB4, we are going to change the password. We are going to change the password of the password we already given. Now clicking RB5, it displays to enter a new password. I already said there is a 4-pin password. We can enter the 4-pin password by clicking the RB3 and RB5. I use RB3 RB4 and RB3 RB4 like one piece, and if we enter that, it says re-enter the new password. Now we want to click that firstly given the password. After that password changes successfully. Now after the checking, it comes to the view log section, and we can see that log is 0 when it's turned on, is the event 1 and the speed is 0. If we change the potentiometer, the speed can varies. This is a demo of my car block box. We can simulate more than like that. We can change the settings, we can use the matrix keypad for that. We can change multiple things. I use as the RB0, RB0, RB1, RB2 are the switches. I thanks once again for this opportunity. Thank you, MSZ. I learned many things throughout the internship. Once again, thank you.